Good afternoon, all of you. Am I audible? Just write in the chat box yes or no. Am I audible? Okay. So I am sharing you my first presentation slides. So how many students are in your class? 19. And only 4 of you are there. So what about others? Shall we wait for some time or start our class? Just write in the chat box. Okay. So let's start our first class. So this is our first class for the subject computer architecture, and you will clearly see that its subject code is 5EC3-01. Now let's discuss. Now this is the subject content. Basically, this course is of 2 credits. So basically, the end term exam is of 80 marks and the midterm exam is of 20 marks because it is a 2 credit subject, right? So just briefly discuss the syllabus content. In the first, I am going to tell you what is the objective, scope and outcome of the subject. What is the objective, scope and outcome of the subject. In the second, just having some problem. Now, what is the objective, scope, and outcome of the subject? And in the first unit, we are going to see what is the basic structure of computer. The functional units by which we connect to the computer, the softwares which are useful to us. Then the important topic is types of instructions and the various types of instruction sets and their formats. um, and the other topics are in the first units are assembly language, stats and queues. Stats and queues are basically the topics of data structure subject, and the subroutines. Subroutine is basically the topic of your microprocessor subject. In the next unit 2, we will going to study the processor organization, how the CPU is being processed, how what are the important elements in the processor, like the ALU and how it is designed, the arithmetic logical unit, the number formats, and how the floating point representation has been done, and its IEEE 754 format. In the unit 3, we will going to discuss about the CPU and its control unit. It's two forms. one is the hardware control unit and the other is the microprogrammed control unit and their differences. And these and this is the main theme for the unit 3, the hardware control unit and the micro instruction control unit. In the fourth unit, we will going to study the memory organization, the memory hierarchy, how the memory has been uh, divided in the secondary memory and the primary unit. Then in this we will going to study also the RAM, ROM, and the concept of cache memory as well as the virtual memory. In the fifth unit, we will going to study the system organization, the input or output organization, the types of interrupts, and the direct memory access, which is also very important and also known as the DMA, and the concept of parallel processing and how the parallel processing has been used for the pipelining concept, and how we can use the pipelining for improving the performance of the CPU. So that's all your syllabus has been configured. Now, these are some of the important reference.
तो कुछ हाँ सर, कुछ स्टूडेंट वेट कर रहे हैं सर आपको वो क्लास लेने के लिए। सर आप एडमिट नहीं करो, उनको मैसेज आ रहा था।
They need to join before the scheduled time, you know. So I am
Yes, sir.
this time allowing them. So now 9 participants are there. Shall we continue? Are there any more students waiting for? Are there any more students there? Just write in the chat box. Sakshi Sarkar, mute your microphone. So let's continue. So these are some of the reference books for the subject. Uh, First book is of Maurice Beno. The first these are the writers. Then this is the book name, and this is the publisher. So first book written by the Maurice Beno, and it's of PHI publication, and its name is Computer System Organization. This is the very basic book and mainly been recommended. And this book is also available in our college library. The second book is written by M. Usha and T.S. Srikanth, and the publisher of this book is Willy, and its name is Computer System Architecture and Organization. These are also very much available. The third book is of written by William Stalling, and its publisher is PHI, and its name is Computer Architecture and Organization. It's very old book. William Stalling book is very old book, but you can also, I mean, easily get this book in our college library and in the bookshop as well. And the fourth book is of Sarangi, published by McGraw Hill, and its name is Computer Organization and Architecture. So basically, you need to go through this book, Morris Manu. It covers all the concepts. So you can refer all other books as well, but the Morris Manu is sufficient for you. Now move into the next slide. Now these are some of the course objectives of this course. First, to understand the structure, function, and characteristics of computer system. Then to identify elements of modern instruction set and their impact on processor design. The third one is explain the different representation of floating point formats as it is in your unit's second. Then the other course objective is to identify key points of difference between hardwired and microprogram control unit. This we will going to study in your unit 3, unit 3rd of your syllabus. Then the fourth objective is explain the memory hierarchy and its various types. Uh, we will cover this in your fourth unit, and the example of the types of memory are RAM, ROM, cache memory, virtual memory, etc. And in the fifth unit we will going to study the to understand the pipelining concept for increasing the CPU performance. So these are the course objectives which are divided in various units, in 5 units of the syllabus. Now proceeding to the next slide. Now the course outcome. Basically, after studying this subject, Amisha Mundra. So what is your question?
सर मोरिस मानो की सॉफ्ट कॉपी मतलब अवेलेबल है क्या नेट?
I think it is available. You can search it. You will find the PDF as well.
ओके
And also you can find the PDF of the solutions of Morris Mano as well.
ओके
If you are not getting the PDF, then you can ask me. After that, I am giving you the PDFs of Morris Mano in your mail. But presently I don't have your email IDs. So first you will search by yourself, and if you don't find it, then you can ask me. Then I will send it to your email IDs. Okay. Now proceeding to the next slide, the course outcome. So after the completion of the course, the student will be able to understand the architecture and functionalities of CPU, understand the instruction set and its different formats, learn hardwired and microprogram control unit design methods, understand the concept of memory hierarchy, virtual memory, and their cost oblique performance issues. If in which memories there is cost, uh, which memories are cheap and which is costlier, and what is the performance impact of these memories. Then learn the concept of various types of interrupts and DMA, right, direct memory access. Various types of interrupts, we will going to study the external interrupts as well as internal interrupts. In the external interrupts, which are interrupted by the hardware, and in the internal interrupts which are interrupted through the softwares. And lastly, from the unit fifth, student will be going to understand the concept of parallel processing and pipelining. So after the completion of this course, you all will be going to understand or learn these concepts, right? Now proceeding to the next slide. So first question is why we all need to study the computer architecture. So these are the points uh, for studying the computer architecture. So first is understand where computers are going. So basically, the computer generation has been in the fifth generation phase. So basically, on studying the computer architecture, we come across what are the latest technologies or what are the latest architecture or the motherboard in internal architecture has been presently there. So understanding where computers are going, so future capability drives the computer world. We know it by studying the computer architecture. uh, so you know that in presently in the laptops, Intel i7 has been predominantly used in these days. So the computer architecture has been keeps on changing through after some years. So for the second thing is that understand high level design concepts. So the best architects understand all the levels by which we can design the devices, circuits, architectures, compilers, and applications. So circuits and architecture are basically in the electronic engineering part. So you all are electronic engineers, so so you need to deal with these devices, circuits, architectures are there. And these are some software parts, like compiler and applications are software parts. So the third thing is understand computer performance. So writing well tuned fast software requires knowledge of hardware. So when we develop software, it basically deals or interact with the hardware. So your knowledge of the hardware will also benefit you in constructing the good softwares which are performing very fast. And the last thing is getting a design or research hardware job or software job. So getting a thorough knowledge of computer architecture, you can get a good hardware job or a software job in a reputed company like Intel, AMD, IBM, ARM, Motorola, Sun, Oracle, Nvidia, Samsung, and etc. companies. So these are the some of the points which are necessary for studying the computer architecture and what is the need of computer architecture, right? So the proceeding to the next slide. So this is the introductory lecture, so I am dealing it from the very basics. Now the constant change technology, so these are the three parameters. First is technology, the second is application domains, and the third is goals. So as you can, you already studied that logic gates in your digital electronics, then the static RAM, then the dynamic RAM. So by these, the technology is growing. Then the techniques, packaging, magnetic storage, flash memory. So these comes under the technology, and these technology has been uh, the change to the application domain, like in the application domains we have desktop servers, mobile phones, then supercomputers, game console, embedded systems, etc. in the application domain field. And the roles of or functions are basically deal with both the technology as well as the application domains. uh, in the roles we have the or the function we have the performance, that we want a better performance system day by day, and its reliability will be would be good. The cost of the manufacturing will be much more cheap cost, and it will be manufactured very easily. Then the energy efficiency, it will use minimum energy for charging, and we can use it around 3 to 4 hours after we charge the laptop or the mobile phone. Then the time to market, the technology will reach the market as soon as uh, it was built. So these are the constant change technologies over the years, over the decades. So the computer architecture is been predominantly dependent on these. All of you are getting it? Just write in the chat box. Okay. So proceeding further to the next slide. So these are some of the design rules for making a good computer. We already good computer or laptop. Uh, we want a low cost a laptop or computer, a low power oblique energy. It can use low power or energy. It can function very well. Its reliability will be very good, then it performs very high. So these are some of the design goals which we going to deal in the computer architecture subject. Before we want to build a computer or laptop which satisfy these goals. The Our goal is to build a low cost system which will take low power or energy. It functions very high performance. It must be reliable and it must be uh, functional to the task. So these are some of the design goals which a computer or a laptop must perform, and we are going to see this in a computer architecture section. Now proceeding to the next slide. So these are some of the applications or domains uh, by which we are going to build a computer or laptop. First is scientific, and the scientific systems are used in weather predictions, genome sequencing, etc. Their need is for making these systems, we need large memory. Heavy duty floating point calculations must be done by these systems, and their examples of these systems are Cray T3E and IBM Blue Genie. These are some of the examples which are going to deal with the weather prediction and genome sequencing, which is basically the scientific system task. The second field of computers are commercial systems. These commercial systems are basically deal with database, oblique web servicing, e-commerce, and Google. So the need of these systems are data movement, high memory, and input output bandwidth. So some examples of these systems who perform these tasks are Sun Enterprise Servers, AMD Operaton, Intel Xeon. These are some of the examples. You can also find other examples from the net as well. These are basically the domains or applications which are different fields. Like the scientific field, we need some other types of systems, and in commercial system we need some other types of systems. So based on the our requirement, uh, the uh, the computer configuration is different. So in the third type, we need a desktop system. So desktop systems are used in, I mean, in home offices, in multimedia and games. These systems are known as the desktop systems. What is the need of these systems? They need in integer calculations, the memory bandwidth, integrated graphics, and network will be there. And the examples of these systems are Intel Core 2, Core i7, AMD Athlon. These are some of the examples of desktop systems. Now, proceeding further to the next slide, these are some other specific field domain systems. Now, the first is the next is the mobile systems. The mobile systems are the laptop system and the mobile phone. So mobile means you can carry them anywhere you like. So you can take the laptops and mobile phones anywhere you like. So need of these systems is these systems use less power, and integrated wireless can also be connected to these. uh, so examples of these are in laptops. You have Intel Core 2 mobile, then the Atom, AMD Thuron are the examples of laptops, whereas the small devices are the examples of small devices are ARM chips by Samsung and other manufacturers, and Intel Atom. So these are some of the examples of laptop and smaller devices. Now the next field is embedded. So yeah, or embedded systems or computers. So microcontrollers in automobiles, doorknobs are examples of these embedded systems. And why we need it? They need low power and low cost. As they need low power and low cost, that's why embedded systems are being manufactured nowadays more often. And basically the electronic engineering engineers are basically deals with the embedded system design. So examples of these embedded systems are ARM chips and digital signal processors. So these are the application or domains in which computer architecture are more predominantly used. All of you are getting it? Just write in the chat box so that we can proceed further. Okay. So proceeding to the next slide. Now basic. Now the next topic is basically here we start our first unit. So introduction part is over. Here we are going to start our first unit, and the first topic of first unit is basic structure of computers. So computer architecture in general covers three aspects of computer design, namely these three aspects of computer design are computer hardware, instruction set architecture, and computer organization. So computer architecture deals with these three aspects. So first we will see the computer hardware. So computer hardware consists of electronic circuits, displays, magnetic and optical storage media, and communication facilities. So these all comes under the computer hardware part. Then the second is instruction set architecture, whose short form is ISA. So instruction set architecture is programmable visible machine interface such as instruction set, registers, memory organization, and exceptional handling. So these all comes under the instruction set architecture. So two main approaches are mainly CISC, which is also termed as complex instruction set computer, and RISC, which is also termed as reduced instruction set computer. These are very important and we will going to discuss each in detail with their differences in the next unit. Uh, the last part of computer architecture is computer organization. Now, the computer organization includes the high level aspects of a design, such as memory system, bus structure, and the design of internal CPU. So these all comes under the computer organization. So so these three are the aspects are the computer design aspects of computer architecture. So these are the basic structures of computers by which computer architecture can be defined. So whenever there is a question, so what do you mean by computer architecture? So you can define computer architecture by using these three aspects. By first is computer hardware, then the second is instruction set architecture, and the third is computer organization. Right. So now proceeding to the next slide. I am going to provide you the notes after uh, I am creating the your class on the Google Classroom, probably today or tomorrow. Now the next topic is functional units. Now, the functional unit, a computer comprises of 5 functional units. So these are the 5 functional units. You can see here that first is the in first is input unit, then the second is output unit, the third is memory unit, the fourth is arithmetic and logic unit, and the fifth is control unit. So these are all the functional unit of a computer. Uh, Proceeding to the next slide for your better understanding how these 5 functional units work. So this is the diagram of showing how the work has been performed through these functional units. So first, you remember that from the input device such as the keyboard or mouse, you can input in the in your program or the computer system through with the use of input device. Then from the input device it goes to the central processing unit. The central processing unit consists of two parts. First is the control unit and the second is the arithmetic logic unit. So from the arithmetic and logic unit, based on your input given from the keyboard or mouse, the arithmetic and logic unit performs the calculation uh, ba- from with the use of arithmetic logic unit, and the control unit provides the control to the central processing unit, and the CPU is in constant touch with to and fro to the memory unit. In the memory unit, you can have the RAM, the ROM, and other cache memory as well. So the two, you can see the direction, to and fro direction has been there from the CPU and the memory unit. And after that, uh, once the CPU perform the calculation part, so this will return to the output device. And after the through the output device can be the monitor or the printer. Through the output device, the user can get the output uh, by with the use of input, and based on the input and the calculation done by the central processing unit, the user get the output, and you can also save this output in the memory unit as well. So this is how these functional unit work in the computer system. So proceeding to the next slide, I'm just we will going to discuss each of these functional unit in detail, because this is a very important question in the exams. Yeah, many of the times they asked the question that what are the different functional unit of a computer system, explain them. So this question comes in the category of 8 marks as well. So you need to draw the diagram of a functional unit and explain each of the functional unit in detail for scoring maximum marks. So the input unit, we are discussing this in somewhat detail. So the input unit, a computer accepts encoded information through input unit. The standard input unit device is a keyboard. So keyboard is a standard input device mostly used for inputting the data. Whenever a key is pressed, keyboard controller sends the code to the CPU or memory. The other examples of input units are mouse, joystick, tracer ball, light pen, digitizer, scanner, etc. These are the other input devices which are used to give input to the CPU or memory. The next functional unit is memory unit. So, a memory unit stores the program instructions, which are also called as code, data, and results of computations, etc. Memory unit is classified as primary or main memory and secondary oblique auxiliary memory. So these are some of the types of memories. Proceeding to the next slide, uh, these are the other functional unit parts. The third part is arithmetic and logic unit. which is also termed as ALU. So ALU consists of necessary logic circuits like adder, comparator, etc. To perform operations of addition, multiplication, comparison of two numbers, etc. So all the calculation part uh, is performed in the arithmetic logic unit of the CPU. ALU is basically the part is one of the part of the central processing unit. So all the calculations are being performed in the arithmetic and logic unit. The next functional unit is output unit. So computer after computation returns the computed results or error messages etc. through output unit. The standard output unit device is a video monitor. You can have the monitor L, LCD or the TFT monitor as well. Other output devices are printers and plotters. We can also get these outputs with the use of printer plotters as well. So this is the function of output, or giving us the return value of the computed result from the arithmetic logic unit, as well as the error messages. If some error occurred, then even then the output unit gives us the error message as well. The last functional unit is the control unit. Uh, so the control unit coordinates activities of all units by issuing control signal. So it basically used for coordination of all the functional unit in order to perform the task in synchronization. So control signals issued. Uh, so last 5 minutes are left. So we are going to hurry up these 2 3 slides, last slides. So control signals issued by control unit govern the data transfer and the appropriate operations take place. The last task of control unit is to interpret or decides the operations oblique actions to be performed. It basically decide which operation will be performed first, and after that which operation will be performed next. So this all will be decided by the control unit. So proceeding to the next slide. Uh, so this is the instruction cycle. So which is of basically of 4 steps. So basically this is the first step. Then the second step is this. Then the third step, and this is the fourth step. So basically, the computer fetches the instructions. Then after fetching, it decodes the instruction. First, the computer fetches the instruction. Then it decodes the instruction and decide what operation it perform. After that, in the third operation, it executes that instruction, and in the fourth, it the result obtained it once again stores in the memory. So these are the instruction cycle which will be performed on and on for uh, for for example, if we want to perform the addition function, then it first fetches the instruction, the first fetches the addition operation, then it decodes the addition into the machine language, then it performs the addition operation, and then it stores the result of the addition into the memory. And in the same way, if we also want to perform the multiplication, then the same cycle will perform once again. And in the execution part, we perform the multiplication operation, and after that we store the multiplication result in the memory. So this is all. And in the summary of computer operation, I am just what I explained in the last slide. I am just writing it here. A set of instruction called a program reside in main memory of computer. Then the CPU fetches those instructions sequentially one by one from the main memory, decodes them, and perform the specified operations on the associated data operands in ALU. All the operations are executed in the ALU. Then the processed data and result will be displayed on the output unit, and all activities pertaining to processing and data movement inside the computer machine are governed by the control unit. Basically, the control unit operation is to synchronize these units so that the the operation will be performed in a synchronized way. So that's all for today's class. So thank you so much. All of you are getting it. I will share these slides once I create the your class Google Classroom for this subject. All of you are getting it. Just write in the chat box. So our next class will be scheduled on I think in on Wednesday, and the timing will be same. 12:15 will be the time for our next classes. 12:15 to 1, because in Cisco WebEx only 40-minute class will be taken. It allows us to take only 40-minute class. Okay, so thank you very much.